This is again Dr. Data Science Office Hour session. Today our speakers are Stephen Hillen, Senior Director of Data Science, and then Vinod Manamala, Senior Data Scientist, who would be talking about today. And before we proceed, I would just like to share every third Wednesday of the month, we have the Dr. Data Science sessions, and the session recording will be posted on YouTube as Dr. Data Science playlist. I would be posting the link eventually during this time. And as you can see, there is a question answer section where you can post the questions during the session so that the speakers can answer them towards the end. And any postings or links, I would be using the chat window to post them. So
Great.
Yeah.
Thank you so much. Thanks, Nalima. Welcome everybody. Good to see you all again. I see a few people coming back time after time, so that's always great to have regulars. And thanks Vinod for joining us today as well. We got a really fun session today that I think will have pretty broad appeal. As usual, we have a quick info gain session at the beginning where we talk about a topic of general interest, a quick tip. Last time we talked about how to look at relationships between variables, whether those are categorical or numerical. And then our featured session was about methods for explaining models, all the way from the sort of transparent models like decision trees and regressions through to more opaque models like SVMs and neural networks. So that was a really useful session, I think. Today, we're going to talk about really about exploring data is really the theme today. First of all, I'll mention that Vinod is here to talk about exploratory data analysis using visualizations, using charts, and we've picked our top 5 charts that we like to use to explore data. Before that, we'll actually use a different method for exploring data, which is actually predicted models. Normally, we think of those as being used for some sort of business purpose to create some sort of prediction or insight, which we're going to share with the business or put into operation. But models can also help us with some of the prep work of understanding data sets. So let me talk about that in our little info gain session. I'm going to use an example of decision trees as a way that I often use to explore data sets when I'm first getting to know them. Here's actually a decision tree that we've added to TIBCO Spotfire. If you're familiar with TIBCO Spotfire, you'll know that it doesn't have decision trees out of the box, but of course we've got now this new capability within Spotfire to add mods. Mods are extensions, usually visual extensions to TIBCO Spotfire that anybody can add. With some fairly simple JavaScript, there's a very easy framework for adding these. One of our interns actually added a decision tree this summer. And it's easy, as you see here, sorry, let me just click on this little video that I made. Easy to select a data set like this, open up the decision tree, has all the usual affordances that you'd expect from a decision tree, expanding and collapsing and modifying whether you see end nodes and the intermediate nodes, and then you can pick a different data set and select the columns that you want to analyze, and then the decision tree will be rebuilt. In this particular case, this is the sort of well-known airline data set. Let me just pause it there. So you can see here, the thing I'm ultimately interested in is whether they're on time or delayed, the flights in this data set. And then I've asked it to look at variables like some of these weather variables. I've just restricted it to the weather variables in this case. And you can see beginning to emerge from this analysis by the decision tree is how those variables relate to the condition of being on time or not, and also how they relate and interact with each other. If we go back to the beginning of this video and look at the well-known iris data set, I sometimes think that data scientists must be the world's foremost experts on flowers and irises in particular, because we all know this data set too well. And here's a great example here. It says that, look, if the petal length is less than some threshold, it's pretty much guaranteed to be this varietal of iris, the setosa varietal. So you know, you can use decision trees in this way, and you can pick different variables and different dependent variables and see how they interact and relate to each other. And of course, you can also use, say, logistic or linear regressions to play the same sort of game and looking at the strengths of relationships between variables. That's actually a feature in TIBCO Spotfire under the data relationships menu. You can use regressions in order to find measures of variable importance. So just a few ideas there about how you can use models to understand the structure of your data set. Of course, I think the most common method is to use charts as a way to explore your data. And so Vinod is here to tell us why he's picked 5 charts in particular as the ones he uses most frequently and why he thinks those are particularly useful. So Vinod, let me stop sharing and you can share your thoughts.
Thanks, Stephen. Can you see my screen?
Yeah.
Perfect, thank you. All right, so today I'm going to talk about the 5 top charts to use in the exploratory data analysis. So let's get to the introduction. So what's exploratory data analysis using visualization, or we just call it as EDV, right? So EDV is the first opportunity you get to gain insights from your raw data, right? So the purpose of EDV here is to create visualizations to better understand the raw data, and you can expose the trends, patterns, and relationships that are not readily apparent when you give a first glance at your data. I mean the raw data. Again, EDV is like a very crucial step prior to building a model because it helps the data scientists to gain various insights. You know what, that becomes like more important in developing a robust machine learning model later.
Yeah, I think for me, when I first open a data set, right, it's just a table of data with no apparent structure. There may be a structure hidden in it, but difficult to tell from a table, especially if it's like a bigger data set, right? You get the preview of the first 100 rows. How do I know these rows and values are representative, right? The raw data doesn't really tell you much at a glance.
Perfect. Okay, so what are the goals for EDV, right? So the primary goal of EDV is like, you need to provide all the specific items, that a data scientist would want to extract from a raw data set that Stephen just mentioned. Some of the examples are like the relationship between variables, the distribution of variables, data scientist wants to know the list of anomalies and so on. So how do we get started? So the easiest way to get started with EDV is to, use questions as tools that will really guide your investigation here. So when you ask a question, you know what happens? The question focuses your attention on a specific part of your data set and helps you decide which visualization should be used to answer your question. So at my first glance at this data, there are like few questions that pop in my mind. For example, let's take the Texas wind station data, and at the first glance, I can look at a lot of categorical variables and continuous variables, and also I'll look at a lot of time-based variables. So some of the questions that pops up in my mind are like, which station generates most winds, right? And also look at the lat and long. I also want to know where these stations are located, and also want to know how the wind speed changes over the season and how the wind patterns differ from one station to another.
These are like wind turbine stations, like renewable energy type power stations?
That's true, Stephen. So there's a demo later that explains why I'm using this data set, and
cool.
We'll go into detail about that.
Great.
So primarily, most of these questions can be answered using most commonly used charts by the data scientists. So let's take a brief look at the top 5 charts before we see its practical application in the demo I just mentioned. So let's start with the histograms, right? So what's a histogram? It's a pretty simple chart used by a lot of people in in a lot of analysis, right? So a histogram here gives us an overview of the underlying frequency distribution of a set of continuous data. So this allows inspection of the data for its underlying distribution, outliers, and skewness. So let's take this example, right? So imagine a company here that makes its thermostats for consumers by offering rebates, and that varies by zip code, right? So a histogram of thermostatic rebates here helps us to understand its range of values as well as how frequent each value is. Right. So from this chart, it can be observed that the distribution is skewed towards the right, and majority of the thermostat rebates were between 100 and 120. right? And only a handful of zip codes here have like rebates over 140 and 160. So next on our list is the frequency charts, right? So how is it different from histograms? So the frequency charts here are to categorical variables, what histograms are to the numerical variables. So frequency charts can be used to display the distribution of a single categorical variable, in this case, the blood pressure of the patient. And it can only take like fixed number of values, for example, like low, normal, and high. So what's so special about the frequency chart? So it shows all the possible values of the variable along with either the frequency or the relative frequency. In this case, the frequency is the count and the relative frequency is your percentage. But in most examples, relative frequencies are most commonly used because they allow you to compare how often each value occurs related to the overall, sample size. Like I said, here our example shows the charts of the medical patients' blood pressure by its own categories like high, low, and normal. As you can see that most of the patients fall under the high blood pressure, and you can look at their frequency and the related frequency.
So this makes a ton of sense to me, Vinod. I think that, I mean, just speaking for myself and my team, probably histograms and frequency charts are sort of ways of determining, like, basically what the variable looks like, what the distribution of values is for numerical or categorical. They are without doubt, I think, the most common charts that I use. One of the first things I want to know is, is this categorical variable, how many values does it have? And is there one that dominates, right? Is there enough variance in this particular variable for it to be useful in a model or something like that? Are there tons of null values? Are there outliers? All that sort of stuff. I mean, there's just a lot to be gleaned from these charts.
I totally agree, Stephen. Thanks. So next, right? So after you check the distribution of the data by plotting the histogram and the frequency charts that just we saw, the second best thing to do is to look for outliers, right? Why is it important? So identifying the outliers is important because there are some times outliers can actually bias your results when you're looking for relationship between variables. So how do I find the outliers? So the best tool to identify the outliers is the box plot, and it's the most commonly used chart for this very particular purpose, among other purposes. So through the box plot, we find like various items. For example, we can find the minimum value here. Also, you can find the lower quartile, that's your 25th percentile. And you can also find the median of a distribution. Also, you can find the median is your 50th percentile. Also, you can find the upper percentile, that's your upper quartile, that's your 75th percentile. And you can find the maximum value of your continuous variable. So there are multiple, inputs that you get from this particular graph. So we can also use a box plot to explore, the distribution of a continuous variable across a strata. By strata, I mean like categorical variables. In this case, it's the iris type. So we can observe that, let's take this example, right? So here I want to see the length of sepal in different species. So we can observe that the distribution of the sepal length for virginic and the versicolor is more spread out. So which is evident by the bigger size of the boxes, right? Whereas the sepal length for setosa is concentrated like around its median, right? And moreover, if you just look at the second box here, that's the sepal length for virginic, you will find an outlier, right? So if you find an outlier such as these, I would recommend you to remove this. So this is how you actually find an outlier using box plot and then like remove them from your data set. So let's move to the next chart. So once you have inspected the distribution and then you have removed the outliers, the next best step would be to understand the relationship between the variables, right? So probably the best visualization for this purpose is use the scatter plots here. So what is a scatter plot, right? So they are like a two-dimensional representation of a data in a Cartesian plane, and are especially helpful for inspecting the relationship between two variables, in this case, like house price and square feet. right? So, and we can also look at the correlation between these variables using a lot of statistics that are part of this visualization. For example, here I just want to explore, a house price and how it is related to square feet, right? As you can see that the house price is on the y-axis and the square footage is on the x-axis, right? And so I can see that there's like a level of linear correlation between these two variables. In the sense, I mean, like, more the square footage, you can see that, the higher the price of the house as well.
So just explain to me quickly, Vinod, there's that equation at the top there of the scatter plot. That's like the regression equation?
Regression equation, that's right, Stephen.
Yeah. So it tells you the precise linear relationship, assuming there is a linear relationship, right? I mean, I guess scatter plots are equally useful when there's not a linear relationship, right? You might look at a correlation just sort of like computing a regression or computing the correlation coefficient, but the scatter plot, but you might miss then the fact that there is actually more of like a log linear relationship or something more elaborate. So the scatter plot allows you to really see that relationship mapped out in 2 dimensions there. Would you agree with that?
Yeah, totally, Stephen. That makes sense. Perfect. Okay, let's move on to the next plot. So the next plot is the time series plots, right? So why is it important to use time series plots? So it's very important to understand, like major trends, major patterns, such as, the trends, seasonality, and irregularity in your raw data, right, with respect to time. So these time charts, right, allow you to analyze the scene. So, for example, like, the time series analysis is used for various applications, such as stock market analysis, pattern recognition, economic forecasting, and, census analysis, and so on. Here, for instance, we have the y-axis here is the, in this time series example, represents the, daily closing price of a random stock for the year 1991. And you can see the trends, and you can also see how the price of the stock varies according to seasons and so on. So this is very important to understand what's happening with your data with respect to the time.
I think we've we've all spent a lot of time looking at time series charts this year, right? Looking at sort of, not just the stock markets ups and downs, but of course sort of disease progression and case rates and so on. One thing I noticed on a lot of time series charts that we've been looking at this year is a sort of smoothing lines, right? So methods for using averages or various functions like LOES for smoothing out the time series chart. That's a pretty common feature when doing time series, right, Vinod? What do people use that for?
Like I said, I gave like various examples, right? So later in our demo, we're gonna like forecast the power output of a wind turbine. So that helps you understand, like, is it worthy enough to invest in a turbine in a particular region based on the weather conditions? So that's a very good example.
All right, let's take a look at the demo then.
Perfect. Yeah, before we jump onto the demo, know that there are like various other charts that can actually complement the process of exploratory data analysis. So here's a great perfect cheat sheet for selecting the the right visualization for the right job.
Cool,
so,
that's great.
Now let's. Perfect, thanks.
Where can people find that, Vinod? Is that something that we can share later, maybe?
Yeah, sure. As part of the YouTube presentation, and we also put a link to this picture, or we can share the picture along with the video.
Great, cool.
So now, you know what? Let's take a look at the practical application of all the above charts that we just saw in a spot file demo.
So this is a project you've just been working on, right, Vinod?
Yeah, it's a pretty interesting wind energy project. All right, so let's get to the gist of this project, right? So, so this is a project about wind energy, and as we all know that the wind energy is quickly becoming a popular form of renewable energy, right? So, analyzing the wind energy is very important, in order to understand the potential future investments both on and offshore. So for this purpose, analyzing the historical data from both wind turbines along with the weather data we can actually accurately predict the expected power output, from the wind turbines, in order to maintain the maximum efficiency here. So let's see how to use Spotfire to get insights around various wind turbines, in the area of Texas. So before that, the thing we need to understand is, the power output of the wind turbines that we're seeing here is like highly dependent on weather conditions that are present at the wind farm. So the wind farms, as you can see here, are represented by the triangular icons, and these are the wind farms, that spread across the area of Texas. So here in Spotfire, we can, begin by analyzing the historical weather data, for in areas where there are plants or already existing wind turbines. And in order to do that, I'm going to select an area like of my interest around the map. So once I do that, you can see that I'm going to correlate my weather condition, in this case, my hourly wind speed, to see how is wind speed helping with the distribution of my, distribution of my wind speed over 10 years in my selected station needs. For example, let's say I want to look into the Abilene station. I can look at my distribution for Abilene station in the blue, and also I can explore the active wind projects that are in that particular vicinity of the station name. And also I can look at all the investments that are made into those wind farm projects around the station name in this frequency chart. And you can see that there is this particular wind farm project where they're expecting to invest around 900 million, which makes a lot of sense. But we need to understand if it's justifiable to invest such a huge amount, for this particular wind turbine project, and how do we do that? We do that by exploring the historical data that we just mentioned that we get for 10 years. And also you can see the, the box plot for various, wind farm projects, and you can see the distribution of the wind speed for each of these projects. And for example, let's say that I take the active project for which, I want to invest like 900 million. I want to see the distribution of my wind speed. As you can see,
that looks a little risky, right? The wind speed is not very high.
Yeah, that's not a great investment. So I can go back to the management, tell them that, hey, you know what, the hourly wind speeds distribution are pretty low, and it doesn't make sense to invest 900 million in that area. And so far, you can also look at and compare like two different stations to see if they're like, statistically significant, or they're like statistically different. And you can look at the dots, and they like fall almost, far away. And the thesis behind this, this chart tells you that these two projects are like different, statistically different, and they have like different characteristics. But if I just look at the, wind speed distribution for this particular wind farm project, I can see that winds are above the median of 13.818 all the time, and it's positively skewed, but we're investing like, pretty less in that area. So that doesn't make sense. So we need to inform to the management to make the right decisions. Before that, we also need to understand the wind characteristics, to make like a robust decision, right? About how you want to, look into the insights of your data. How do you want to clean the data? And how do you want to like present the data before sending them to create a, a multivariate model? For example, I'm just looking at my wind characteristics, and as you can see here, I'm looking at my wind data, for wind characteristic, like the weather data for 10 years. And for every month, you can see that the wind pattern is more consistent, and there's very little variation. So I can, with certain confidence, tell that, hey, the wind speed doesn't vary much, and over the years in this certain wind stations and wind farms. So it's like a very less risky project. So you can go ahead with your wind farm project and so on. So once you're sure about all this, you can also take a look at how each wind turbine performs with respect to the wind speed. For example, let's say that I choose a turbine called Enercon, and I want to see its peak output and for what wind speed does it really give me the peak output. In this example, you can see, for let's say I want to do this. Let's say Gamesa turbine. I can see that the peak output is 4,500 kilowatts when the wind speed is around like 12 miles per second. And I can see its power output over days for the certain wind speed here. So now I'm pretty comfortable with my data. So what I do is I would actually send this data into my Team Studio data science platform and build a model around the multivariate auto-arima model. And I want to predict my expected power output for next 3 months. Once I do that, I want to bring back the data into Spotfire. Like I mentioned, this is a TIBCO data science studio platform, which is really very well integrated with Spotfire. So once I bring back my predictions, I want to see how my actual power, power is comparing against my predicted power from the analysis. As you can see that I'm using my scatter plot, I can see like a very good linear relationship between those two variables, and pretty comfortable with my predictions. And you can also see the histogram for the wind speed to just get insights from the distribution, and you can see that. For a certain wind farm, I can see most of the wind speed, revolves around between 10 or 15 miles. So it's pretty high most of the time, and it makes sense for me to go ahead with my investment in the wind turbine project. So once I have my predictions, I can also take a look at my predictions, across the time, by comparing it to my historical data. So I can choose like a wind farm project. And I can say that, hey, for this wind farm project, I want to see how the predictions are for a certain turbine. So let's say I choose a GE power. So these are my, these are my historical data that tells these are the power generated previously, and these are my predictions from auto-arima model that I just created in my TIBCO data science platform.
That's very cool. So if I can summarize here, make sure I've understood you. You've got all this historical data, and my understanding, right, is actually very difficult to get your hands on all of these different data streams from various stations, from weather stations, from the turbines themselves, as well as the specs for the turbines. And you've visualized this so that the user can understand how this has changed over history as wind speeds change over history, as new turbines are brought online. But more importantly than that, you're actually using these predictions, using ARIMA, to say, well, look, wind power has been changing over time as, say, climate changes. And so some of those investments you're planning to make may or may not be so great based on our sort of prognostication of what's happening with wind power. And this is something that we're, I think you guys are producing a webinar about this very topic, right? Is that right, Vinod?
Yeah, that's true, Stephen.
So that's really great. And I'm also going to give a plug for a previous Dr. Data Design session where we talked about ARIMA specifically. Give us just 30 seconds on what auto ARIMA is, Vinod.
Yeah, sure. So it's just an extension of our, the ARIMA model, but in auto ARIMA, what happens is, in ARIMA, you need to manually input like PDQ values to actually generate a model across your time series. But what auto ARIMA does is, it takes a certain range of PDQ values, then it tries to fit all the values across the range that you just inputted, and it finds the best model for you, and it will actually use that model for your predictions here. So
that's
it's
great.
all done on.
Right, for sure. I remember that's one of the things that Nora talked about, is sort of determining what those parameter values is for ARIMA is pretty tricky. So this is useful. Well, Vinod, this is great. It's a great illustration of how these charts are used to really bring your findings to life in this project. It's a really interesting project by itself, but I like how it illustrates the power of all of these visualizations, the histograms and the scatter plots and the time series, especially, and some other ones here as well. The map charts are really great. Nice job. Thanks very much. Nilima, any questions for us to answer in the last couple of minutes?
Yep. Yeah, there are a couple of questions. Let me read out first question. When dealing with multiple variables, is it advisable to use three-dimensional plots to understand the relationship between variables? If no, is there a better way to visualize it?
Okay, perfect. Yeah, I know, when you're dealing with multiple variables, it's actually tempting to make three-dimensional plots. But sometimes it can be really difficult to understand the data, inside a 3D plots. So I wouldn't recommend that. So rather, I would recommend you to create like a scatter plot of relation between each variables, or also you can create a combined chart. That is a great way to visualize the data. So what happens when you create a combined chart is like you have multiple charts that tells you the relationship between each variables on x-axis and y-axis, and and each chart becomes very simple to understand on its own.
Maybe a quick addition to that is not totally answering the question, but related is really the point that I was making at the beginning, is if you've got multiple variables and you want to understand the relationship, of course, at a certain point, the human brain runs out of dimensions. So using models that can tell you, say, measures of variable importance in the case of like a random forest, for example, is pretty good at that, or maybe a regression, or again, using these decision trees to see how variables interact with each other, that can be a useful method as well. Maybe one quick more question, Nilima?
Yep, one more question. Since we are running a little over, probably this would be the last question.
Okay.
I have a data set that has very large dimensionality. How should I effectively visualize these kind of data sets?
Perfect. Yeah, it's on the same lines like what Steven just said, right? So when you're dealing with large dimensionality, you can always reduce the dimensionality using some of the models. For example, we can use like principal component analysis. You could use LDA or any other techniques, and you can make a plot of the reduced variables, right? This becomes less complex, and it's easier to visualize data when you have like high dimensionality.
Great. Okay. Well, maybe just very quickly, I'll mention next month's session. So that's going to be, again, as Nilima said, on the third Wednesday, so November 18th, and we're going to be looking at neural networks, something that we've mentioned a couple of times here and there, but haven't really gone into in any great depth. We've certainly compared neural networks with other models. I think that was our very first Dr. Data Science session. But Nico Rode is actually going to be back to dig a little deeper and talk about the different types of neural networks, when to apply them, and actually talk through a real world case.
Okay. Stephen and Vinod, if you have a minute, probably a last question.
Oh, okay.
How about the setup of the TIBCO data science like admin? How do you set it up? It's more like, I think, a setup question.
Okay, right. Yeah, so Vinod did indicate there that he was using TIBCO data science for the time series predictions in his model. How you set that up? Well, I think that's a topic for another Dr. Data Science session. Maybe you can communicate with us directly through the Dr. Data Science page and shoot us an email, and we can give you some instructions on that. There is documentation on installing TIBCO Data Science. If you just search for TIBCO Data Science Team Studio, administration and installation, I think that'll take you to the right place, and we can also send out the link later. Okay, thanks.
Thank you, Stephen. Thank you, Vinod. Thank you for attending the Data Science session. See you all next month. Thank you.